In this lesson, we're going to learn about linear models. And if you think about what the word linear means, it's right in the word itself. Linear means that it's going to create a straight line. And values or equations that have a straight line, they also have a constant rate. And that is also referred to as the slope. So ways that we've worked with finding the slope is comparing two coordinates and using our slope equation, y2 minus y1 over x2 minus x1. And we've also used the equation that's in the form of slope-intercept form, where it's y equals mx plus b. And m in this equation represents our slope, and b in this equation represents our y-intercept. So when we're comparing to see if a relationship is a linear model or it's a linear relationship, it should have a constant rate, and that constant rate is the slope. If our equation has a constant rate multiplied by something else, then it is a straight line. It's a linear relationship. If you can find the slope, so the rate is always the same, think of this in terms of money that you might make at a job. If one day you worked and you're making $10 an hour, your rate is $10 per hour, so the slope would be 10. However, if you are working and your boss decides that, well, on Mondays you get paid $5 per hour, and Tuesdays you get paid $6 per hour, but on Wednesdays you get paid $10 per hour, that's not a linear relationship anymore because the rate is not the same. So in order for something to be linear, you have to have the same rate between the different values. So again, think of linear relationships is we're comparing the rate of change between points, which we've learned is our slope, and the rate of change must be the same between all values that you're comparing. So in our money example, if every day you're getting paid $10 an hour, that's a constant rate. But if each day of the week changes how much you get paid, it's no longer linear. So this is an example right from the lesson. Francesca makes an initial deposit of $100 into her checking account. Each month, she deposits another $25. Assuming she never makes a withdrawal, the balance in Francesca's account is given by the equation B equals 25t plus 100, where t is the time in months. Is this a linear model? If so, give the slope and the y-intercept. So think about this equation right here. This equation is showing us that she starts off with $100, and every month, so t is month, every month she adds $25. This would be a linear model because each month it's incrementing by the same exact rate. Every month she's adding another $25. So on week 1, she adds $25. Week 2, she adds another $25. Week 3, she adds another $25. So this rate, we're multiplying by the number of months. So on 1 month, it's times 1. 2 months, it's times 2. 3 months, it's times 3, and so on. So this is showing a constant rate. And if we look at this equation in terms of slope and intercept, think about our slope-intercept form of an equation. We had y equals mx plus b, where m is our slope and b is our y-intercept. So in our equation, the number multiplied by t, this is our rate. So our slope is t. And our y-intercept then is 100. And the reason why this is it is because when she's starting her checking account, she had a beginning deposit of $100. That's your initial starting point. That's what that y-intercept is showing you at a value of 0. So at 0 months, she has $100. After 1 month, she has $125 because she is adding another $25 per month. Another example also within the lesson, Julia has a savings account from which she makes monthly withdrawals of $250. The balance in her account can be shown by the equation B equals 8,400 minus 250T, where T is the number of monthly withdrawals. Make a table of reasonable input values, and then determine whether or not this is a linear model. If it is, give the slope and the y-intercept. So just right away, looking at the equation that's listed, this is showing a constant rate because every single month she's deducting from her checking account $250. So that constant rate, or the slope, is a negative $250. She's subtracting $250 every single month. So this is a linear relationship because it's changing by the exact same rate every single month. So in terms of an equation now, if we have to identify the slope and the y-intercept, the slope is always the constant rate. So however much it's starting with or changing by each month, so 250, it's subtracting each month, that's your rate. That's always going to be your slope. And then the initial starting balance, this $8,400, that is your y-intercept. So that $8,400, that's how much that Julia is starting off with. Then after 1 month, she deducts $250 or withdraws $250. Another month, she's withdrawing another $250. So your y-intercept is a fixed amount. That's where you're starting from. The rate, or the slope, is how much it's changing after each amount. So after each month, in this case, it's changing. Another example, we can compare rates with equations or with graphs. The key here is we're comparing the rate. So in this first example, this equation is gas station A. So station A, we are using the equation y equals 3.75x. So this means that the price of gas, here is our rate. The price of gas is $3.75 per gallon. Per gallon. So the rate here, $3.75 per gallon. We can see the rate right in our equation. This is where the slope is. Y equals mx plus b. And in this case, there's nothing to add, so it would be plus 0. So our rate right here, this is our slope, $3.75. So for gas station B, they're giving us a graph. We have to calculate out what the slope is from this graph. So we would need to find intersecting points. So one for sure we could use is the point 0, 0. And this is another coordinate we could use. That's the point 1, 4. So if we calculate out our slope, just based off of the graph, I have a rise of 1, 2, 3, 4. And a run of 1. So that would give me a slope of 4 over 1. If I used my slope equation, so slope is equal to y2 minus y1 over x2 minus x1. You're subtracting your y coordinates. So 4 minus 0. And subtracting our x coordinates, 1 minus 0. Simplifies to 4 over 1, which is equal to 4. So this means that the price per gallon, the rate that we found, the price per gallon is $4 per gallon. So station B has a higher rate, making gas station A less expensive. So you need to compare the rates. In an equation, it's the value multiplied by x. In a graph, you can calculate by counting right on the graph the rise over the run, or simply use your slope equation to calculate out the slope. So just a quick shortcut for determining if an equation is linear or nonlinear. If an equation can be written in slope-intercept form, then it's a linear graph. So for example here, I have a number multiplied by something and then adding a value. this looks a lot like slope-intercept form. Slope-intercept form is something times x plus or minus a value. So each of these equations are showing slope-intercept form relationships. They're all linear. Even though this one looks like it has a little bit more, you could multiply 0.07 times 2499, and it would still look like slope-intercept form of an equation. These ones, I gotta drag my window down a bit. These ones are example of graphs that are not linear. It doesn't look like y equals mx plus b, mainly because this one has an exponent, and this one has a variable raised to an exponent, and this one is a variable exponent. So examples of equations that are not linear, they have exponents involved, or you're dividing by a square root or something like that. All linear equations look similar to our slope-intercept form equation. So just to summarize, if the rate is not constant, it's not a linear relationship. And by rate, I mean slope. So for example, there was an example on the quiz for babysitting rates. And like the money example I gave you before, if you're making $5 on Monday, $6 on Tuesday per hour, and $10 on Wednesday per hour, the rate isn't the same. It's not linear. In the babysitting example from the quiz, one kid was $6, 2 kids is also $6, but 3 kids is $7. That's a different rate per kid, so it's not a constant relationship. Next one, think of slope-intercept form for linear equations. If your equation looks like slope-intercept form, where you've got a number multiplied by a variable, and then there may or may not be something added or subtracted, then it is a linear relationship. As long as there's no exponents involved or dividing by irrational numbers, then it is a linear relationship. And as you're going through the lesson, you are comparing the values as a rate. So think of slope. How can you find the slope of the equation? Or how can you find the slope in terms of the graph? These are all things that you would need to do to determine if something is a linear relationship.